Hi, this is Tracy, and this is our project, which is a volume meter that is based on a voltage divider concept. We're using op amps and voltage dividers. The schematic is as seen here. We have a number, actually 8 comparators. We use the 348, the LM348 integrated chip op amp, containing four comparators, and we have 8 of them connected to diodes. And based on a voltage divider, as there is a voltage dropped, the voltage is divided, and different diodes light up in sequence. So we try passing through a sine wave with a 12 volt, positive 12 volt and negative 12 volt power supply. And we use the 1K resistor between each of the comparators and diodes in order to produce an effect. And the one we observed is lighted up here. The wave that we put in is a 5 volt peak to peak sine wave at a frequency of 1 hertz, which is very observable as it takes 1 second to cycle through. And we also chose a lower amplitude in order for the light to be visible but not as bright. And so we also picked a positive 12 volts and a negative 12 volts as the power supply. That would be the VE and the negative VE.
Hi, I'm Jingyan, and I'll explain how the circuit works. So basically we use 2 op-amps, and the op-amps here function as the comparator, which means if the V positive is larger than the V negative, the gain would be 1, and if it's smaller than the V negative, the gain would be 0. So it's kind of like a filter. So it's like when the V positive is larger, the current will go through the circuit, and the LED will be will glow. So because the sine wave, the input is changing all the time, so the V negative is also changing all the time. So sometimes V negative is larger than the V positive, sometimes it's smaller. So the LED lights glow like this.
Hi, my name is Tracy, and this is the part 2 of the lab where we use a transistor instead of an op-amp in order to produce the same volume meter result. Here we use a simplified circuit with only 3 LED lights lighting up in sequence. Right now we are passing a 4 volt 1 hertz 4 volt peak to peak and 1 hertz sine wave into the circuit. And here I'll explain the circuit layout. So it's very similar in concept to our original volume meter. The only difference is that we're using diodes instead of certain 1K resistors in order to create the voltage divider, and instead of the op-amp we're using an NPN transistor in order to create the comparator effect onto this blue, green, and yellow LED. So they are also in a sequence. And for more detailed circuit diagram, you can look at the modified diagram, but the concept is the same as the op-amp circuit we had earlier.
Hi, this is Jing, and I'm gonna explain the theory for the part 2. So we use these 3 transistors here, and this is VE, and the middle one is VB. So this is how it works. When only when VB is larger, 0.7 volts larger than the VE, can the circuit run. So only in that way, there will be currents going through the LED, and it will glow. So at first it won't glow because the VE is grounded, which is 0 volts, and the VB, at first there was no input, so the VB is also 0, so it's not working. But when we put into the sine wave, there will be the VB will rise from 0 to 5 and then come back to 0. So we can see here it glows sometimes and sometimes it doesn't. So here are 3 diodes which function as the voltage divider here. It serves to divide the audio signal to gradually decrease. So we can see it. The second and third one glow slower than the first one because it needs the input to be larger so that they can glow.
Hi, this is Tracy, and right now we will demonstrate how the voltage affects the input of the results of the LED lighting. So right now you can see all of the lights are shining. We are passing a sine wave with an amplitude of 4 into it, and right now I will decrease the amplitude by 1, so it's 3 volts peak to peak. As you can see now, the last LED is not lit, and only the first 2 LEDs are shining. And this result is because of the voltage divider. Finally, we will decrease the voltage by 1 more volt, so it's a 2 volt sine wave. And as you can see now, there is only one LED diode that is emitting. And this clearly demonstrates the voltage divider effect that we wanted to show through the circuit. The waveform for our LED 2, the second diode, during a 5 volt peak to peak sine wave input at 100 hertz in order for the program to work. And as you can see here, the white refers to the voltage, the red refers to the voltage through the diode, and the blue refers to the input sine wave. Due to the use of our NPN transistors and the specific setup of our diodes in the circuit, there's a phase shift that is very clear from here. As the voltage increases, the output voltage from the transistors, which leads into the diodes, decreases. So they're inverted, as you can see in this figure. Also notice that through the voltage of the output, you can clearly see moments when the LED is on, and then when voltage is 0, the LED is off. So you can see moments where the LED is on through the second diode, and this can be shown through the lighting up and dimming of our LED.